So welcome and thank you so much for joining another webinar from Growth Acceleration Partners. First, I want to give you a brief overview of our company. GAP, or Growth Acceleration Partners, as we usually call it, is a strategic technology solutions company that provides exceptional experience in digital transformation, software solutions, and data through our world-class consulting and engineering teams. This webinar is part of our event that's called the Cloud Fest. Today, we have Santiago Rando, who will be presenting the topic, Oops, the app is down. Avoid this scenario by building unbreakable HADR architectures on Azure. To tell you a bit about Santiago, he has worked in the software industry for 13 years now. He has had the opportunity to be a full-time developer, then a technical lead, and now he has the privilege of being a software architect. He mainly works with Microsoft technologies, .NET, and Azure, and additionally, he's an advocate for AWS and machine learning. So welcome, Santiago, and now the stage is all yours.
Okay, thank you, Camilo, for the warm welcome, and then again, welcome everyone to the speech and taking this time to be here today. So yeah, as Camilo was saying, today we are going to be talking about unbreakable systems into the Azure side. So for sure, everyone was around last week when we have a global outage where a lot of applications that were deployed into the Azure infrastructure and also services that were related to Microsoft caused a massive outage, even affecting airlines, hotels, and systems like that. So this actually comes into the point to this kind of talks that we are going to have today. So in order how we can prepare properly in order to survive these kind of scenarios without major hiccups, and how we can exploit the Azure technologies that we have available so far in order to achieve a high available system. So the first thing it will be to clarify the part of the title. So we have the HADR acronym in here, which is going to relate to high availability and disaster recovery strategies. So this is when we start talking about designing systems that we need to minimize the downtime that we have in our application when there is an outage in maybe in a particular region of the system, maybe an unavailability zone of our product, and even in some cases how to try to survive in a global outage like the case that we have last week. Having a high availability system and a plan for disaster recovery also involves have a proper plan to ensure data integrity. And we also need to have a proper plan in order to recover from failures. So in order to achieve those kind of things, you have to define initially what are your priorities. This is actually pretty important to know what you want to achieve, because based on the type of business that you are trying to run and what are you trying to achieve with your high availability system, you might have different things. So, for example, you might need to have a high service level agreement objective with your user. That means you want to have your system fully available as much as you can. In this case, this is usually for applications that need to provide user with almost a 24/7 service, and they don't have the luxury to be out at any moment. Or maybe you are more concerned about actually having a recovery time objective. So in case your application goes down, how much time do you actually can have the leisure to be down? Maybe some applications can be out for maybe 5, 6, 8 hours, maybe half a day, and doesn't have any negative impact on the end user. And maybe there are applications around like can have the luxury to be out like for more than 5 minutes. So this is pretty important to define your recovery time objectives. And the other piece is the recovery point objective. This is actually also pretty important to define. In this case, we are talking about how much data are you willing to lose in case of an outage. So if your system goes down, are you maybe ready to lose 1 hour of data, maybe 2 hours of data, 6 hours of data, or you don't have the luxury to lose any data? Like, for example, a banking system or a transaction system, they don't have a luxury to lose data. That will be a huge impact. This doesn't mean that you have to choose one of these three. You can actually make a work between all of those items, because maybe you have a requirement to have a high level service objective of this availability for your client, but at the same time you have to require a recovery point objective where you need to protect your data in most of the cases. So you need to find the balancing here. But it is important that we are building any system architecture, whatever we are using, Azure, AWS, GCP, on premises, we have to talk about having trade-offs. So in order to be able to achieve this kind of solution, you have to start thinking about building mission critical application. And the first thing that you need to take into the account is the maximum reliability that you would like to achieve on your application. So this is pretty fundamental in order to build solutions that are actually reliable. So we speak about reliable application, are applications that are trying to serve their clients as much as they can throughout the year with minimum outages or very small time windows of outages and an easy recovery plan. Also, part of a mission critical application is the sustainability, escalation, and performance of an application. It is almost impossible to talk about a high available system if your application is unable to scale properly based on the user demands in whatever place it is deployed. Because you could have a mission critical plan, you could have a high availability disaster recovery plan, but if your application doesn't escalate properly to the request, of course, eventually it's going to be a failure that is going to be more transient into the infrastructure design that actually into the availability plan. You have also to take into consideration the operation by design. You have to engineer your application, making sure that everything is robust as possible from the engineering perspective. So here it comes into play architecture like event-driven application, event sourcing application, or the couple architectures that allow you to survive without one component being offline and the other may be available. So this is this is very important to think your application to be highly available and being able to adapt to failures. And of course, like anything, you will have to make sure that your application is always secure because this is one of the biggest boundaries for a proper mission critical application. You have to set up your security boundaries in all places throughout the application, only expose whatever you actually need to throughout the internet. You need to use the proper cloud resources to keep your application secure, isolated from the public in the places that you can, and make sure that everything has a proper set of security throughout the middle. Because the same thing, you could have a high design and actually a highly scalable system to survive any kind of metrics or demands your product is actually having. But if you have an insecure application, it's going to be very likely that the surface of attack is going to be open for attackers to use them, and that is going to cause eventually a failure in your system. And then again, something that is pretty important for the mission critical application is the cost trade-offs. One of the things for mission critical application is that it could be more expensive than the average application because you will need to require to have components in different regions. We are going to see cool examples of services that allow you to do that in Azure in a few slides. But you have to be very wary of the cost that you want to achieve in your mission critical application. Because if you want to keep your cost very low, you maybe are going to sacrifice part of the things that we spoke earlier, maybe the recovery objective point or maybe the recovery time, because you don't want to have too much infrastructure available to survive, or you want to make things a little bit more on demand. So that is going to reduce cost, but it's going to increase things like your recovery time objective or the recovery point objective that you can target. So cost is one of the major pillars in here, and you have to be ready to make proper trade-offs in the industry when you're building an application on this type. So when we speak about Azure mission critical application, you have to think about different concepts in here. This is like the most important concept that you have to keep into your application. Of course, the application design actually in here, as I spoke previously, it is crucial. You have to make sure that your application is properly designed to escalate to the demand. It is actually prepared from the coding and infrastructure perspective in order to survive if one of the components goes down. So if you have an API and you are using maybe a queuing system in the middle and the queue system for some particular reason goes down, you have to make sure that your application is properly designed, that those messages do not get lost when the service is actually down, and the processors and the consumers of those messages doesn't feel like any effect of that kind of outages. Or maybe the services that are consuming your messages goes down, you do not lose any message. You have to make sure that your application try to keep a huge consistency with the user demands. Of course, this also involves the data platform. Everything related to data has to be properly secure. So in here, you have to think about strategies to keep your database replications in several regions or several locations, just to make sure that data integrity is safe as possible. We will talk a little bit more about this part in detail later. Of course, security, like I mentioned, this is a huge pillar in a successful application. A proper security standard laying in all your in platform strategy and also your application strategy is going to be crucial for a successful system to survive. Networking and connectivity is also one of the most important things. How you design your infrastructure and networking on the Azure side, especially, is going to define a lot how your system is going to be available. A poor design of a networking is going to cause hiccups in communication between several services. So you have to be very wary about the networking infrastructure that you choose and how do you split your resources to be located in one networking into another one, or maybe using subnet or hubs into the Azure side. The application platform is actually pretty important. It's a huge connection between the application design and the data platform as well, because the application platform that you choose to sustain your application is going to also dictate how available is your application. So using technologies like containers, Azure Container Apps, Kubernetes, Web App Services, and services like that are going to be able to provide you with a coverage of availability based on the structure that you also choose to maintain your services or your application platform is going to be crucial in the case of the design as well. For the operational procedure, is going to be everything that is related how you are going to operate your platform and your system as well. So how you are going to recover from those issues. You are going to have an active solution, are you going to have a passive active solution, or you are going to leverage into the CI/CD pipelines in order to restore your application? We will see that in more detail later as well. Something that is heavily crucial for high availability application is also the health modeling. That's why, because the health modeling is actually one of those components that is going to dictate when one of your components is actually unhealthy, and we need to take action based on those kind of things. So these things goes into very simple things like web APIs, health checks, endpoints that the developers can build, create custom by themselves. And this also goes to supporting by yourself using the Azure technologies and the Azure portal in order to make sure how a service is actually available. So Azure is going to let you know if maybe there is an outage on the Azure SQL, maybe in the Cosmos DB, some kind of communication issue. And mostly any service Azure is going to provide a health model in order you to support your application and know how to react to those failures. Of course, the deployment and testing is going to be crucial. We are going to talk about this later on, but how you deploy your application and how you test your application is also going to dictate how high available and how resilient your application is going to be. So since we are talking about Azure, we need to make sure that when we are building application, we design for something that is thinking a cloud native perspective. Maybe this is the first time that you heard the cloud native. This is already a standard that is defined into the industry. One of the biggest pillars in here is that when you are working with a cloud provider, you need to lose like the fear of using the cloud technologies. So it's actually very common to see companies that are today on premises, they decide to move into the cloud and they keep all the infrastructure exactly as they were working on premises. They try to maintain manually VMs, they try to manage hard drives manually as well. They try to manage their databases fully manually using VMs, having a DBA, making all the administrating process. And just to be clear, that is not exactly bad, but it's not going to allow you to exploit the cloud capabilities. Maybe there are some businesses that could be well served in this kind of implementation using VMs, or maybe dictating some kind of legislation on the industry. They need to manage the data by themselves. That's okay, and there are cases that usually happen. But if you are a business that can actually exploit the cloud technology, you should actually try to do these kind of things. So when working on the cloud native, start thinking on services like, for example, Kubernetes. This is actually a good platform to deploy container applications that have a good amount of microservices that you need to interconnect your application one between the other. You need to escalate your application even in a smaller system, like into the Kubernetes side, and maybe escalate the resources of the whole core Kubernetes cluster by itself. So using this container approach is It's pretty useful. In case that you want to maybe try to keep things simpler, you can use things like the Azure Web Service or web apps in this case to deploy your web application, reducing the amount of management that you need to do, and worry what you actually should be worrying more about. Keeping your application highly available and make sure that your developers are busy doing code. This is the one of the most important factors in here as well. Do not fear to also to dictate and go through custom services for databases like Azure SQL database. Azure SQL is going to provide the same service as standard SQL database has to offer, and even with additional services, and is going to remove a lot of the overhead that you have to do when you try to manage things manually. It's going to take care for the backups for yourself. It's going to take care of data replication in different zones or different regions where it's actually needed. And in the case of a failure, the Azure SQL can easily move the endpoints one into another instance in case there is an outage in a particular place the database can be deployed. Azure Cosmos, we are going to be talking about this service in a little bit more detail later. But Cosmos DB is actually a great service because it allows you and gives you a huge flexibility when you are working on the Azure side. You don't only will only have access to a non-structural database, which increases the flexibility in your system if you know how to use it properly. But it's also going to give you global distribution of your data. It's going to provide maybe one of the highest availabilities of data throughout the in services in the Azure side, and it's going to provide a bunch of APIs to consume the data in different ways. And since we spoke a little bit about disconnected application using event-driven systems, for example, here it comes services like SignAlert. So remove that thinking of using polling APIs, checking for information all the time doing manual requests, or trying to open WebSockets manually in an insecure way. Try to adopt technologies like SignAlert in order to communicate between your different clients and products in a sync manner and almost in real time. So, well, we spoke about cloud native and some of the services that we have and some of the things that we need to have in order to have like a mission critical application. So let's start out talking about a huge factor in a high available system. And in this case, is the data replication that we could have into an application. So this is going to serve and depend according to the requirements your business has. So let's see. So we could have global replication of your data. We could have regional replication of your data. We could have some replication of your data or not have replication at all. So when you are trying to keep your data safe, it is going to depend what you want to actually to protect and how important is that information. If maybe you are a small system that is only maybe available in a website to maybe some particular users in maybe in a few cities that are located in the same country or on a very close vicinity, maybe you don't have to keep a replication at all. Keeping into consideration, maybe your data is not it is not sensitive, or in a case of losing data, it's not going to affect your end client. So, of course, keeping no replication is going to be the cheapest option in the Azure side, but of course have trade-offs. If your system has an outage or there is an outage with the resource that you are trying to consume, you are going to lose data. Now we can have the zone replication. This is when we can replicate our data inside the same availability zone in our system, and we can replicate that data into different zones. So in this case, this is going to protect you in case there is a failure in a data center located into the Azure side, let's say East US. So there are different servers in the same location in this case. So if one of the data centers that is located in the East US goes down, there is maybe, I don't know, maybe a flood, an accident, and maybe a huge electric outage, internet outage. If you have a zone replication, another server that is located in the same region can keep your data safe and have that replication ready for you just in case of an outage. But if you say, let's say, have a more robust system that actually need to protect more the data because it's more sensible, you can have the luxury of losing data in for your client. Maybe you need to move into a region replication. So let's say you are operating an application that is whole countrywide. So let's say you are operating in whole Colombia or the whole United States, and you need to make sure all your users in that particular country have access to your application, and you need to make sure you protect the data for all those users. So in this case, you will be well served using region replication because you will stay within the same location, but you are going to be supporting different abilities. So for example, your main application could be deployed into the East US, but you can keep a replica of your data maybe in the East US too, maybe Central United States. You can keep replicas of your data in different regions. So that is going to increase the protection of your data. And the use case scenario is especially when you are serving an application that is worldwide, serving users throughout the globe, and you need to make sure that you protect your data. So in this case, you have users in the United States, and if you want to protect the information for the users of the United States, you can replicate the data into the West Germany. As an example, is a region replication. Maybe you want to replicate your data into Brazil just to make sure maybe the latency is actually lower in case of a failure. But that is going to give you a huge protection of your data because it's going to reduce the room of a failure in the system. So then again, following the same logic, so you are going to have the locally redundant, sun-redundant, and geo-redundant replication and geo-sun redundant. So this drawing actually depicts what I explained. So the more you move into the right, more replication is going to have, and more security you are going to have that your data is going to be fully protected on the Azure side, but more expensive is going to be. Keep that in mind. Now here it comes one of the most important topics also when you speak about a high availability systems into the cloud is how you are going to escalate your system in order to achieve a high availability on it. So for example, let's take the Azure Kubernetes service, or let's talk about Kubernetes as a standard service. When you are working with Kubernetes, you have the option to escalate your service inside the Kubernetes itself. So in case you are not familiar with Kubernetes, when you deploy an application into it, you can choose how many containers are going to be available to serve that particular application. So you deploy an API, and you can say throughout the YAML definition, okay, this API is going to have 3 different pods. You can translate pods as something closer to be a standard Docker container as an example, or any container that applies the standard, and that API is going to have 3 pods serving the user. So when a user makes a request, any of those 3 pods will be available to take the request from the user and make the process that the user requested. When you go to the scale of unit in Kubernetes, you can have elastic escalation throughout the Kubernetes itself. So eventually, maybe you can increase your demand from 3 pods to 10 pods because you have too many users available. They are making a lot of requests. So you can prepare your Kubernetes cluster and your deployment in order to escalate the amount of pods that you have available in your system. And once the demand goes down, you can go back maybe to the 3 defaults, or maybe you can go back to the 2 default. And maybe you have even the luxury to make sometimes your client way, you can fully disable the amount of pods that are available. You can set it to 0. And when you start getting requests once more, you can create pods by demand. That reduce the cost, but there is a trade-off that some of the requests that are in the middle of that activation are going to have an additional delay. So everything again is about trade-offs. Why the scale of unit is actually pretty important, because how do you escalate your application and which scale unit you choose is going to dictate how your application is going to behave. So let's take as an example one of the well-known services in Azure, the event hubs. This is one of the systems that you can easily use to move massive data throughout your system. You can send messages to Event Hub using streaming services. Even like a protocol like Kafka are available to connect to Event Hub and consume the Event Hub as a Kafka service. So you can send messages. You can split everything using like similar to the Kafka technology. You can create topics and streams to subscribe to different product, and you can have many subscribers to the Event Hub. One thing is that Event Hub is dictated throughout something that is known as the throughput units, and this is going to dictate how many requests or how much load your system is going to take. So this is another example of a scale of unit, because if you define a throughput unit that is too small, like TU, or many of few units are defined in your application, if you start having a lot of amount of requests sending messages to the Event Hub, eventually your Event Hub is going to throttle and is going to stop taking requests causing massive delays. But also in the core of the contract, you have to be very mindful because if you choose a throughput unit a scale that is too big, it is going to be too expensive, and maybe you are going to be wasting resources in these kind of things. So knowing your system is actually pretty important. Also to choose the throughput units or the scale of unit that you are going to be choosing. Pretty similar actually happens with Cosmos DB, which is based on request units. And in this case, it depends or dictates the scope of the scale unit. And it's going to be the relationship between the amount of requests that are going to the Cosmos DB between the writing and read operations in this case. So the same logic also applies. If you start making a lot of requests to the Cosmos DB and your request unit is actually pretty small, eventually Cosmos is going to throttle the request and start even rejecting those requests in case there is an exit of the consume. Then again, choosing the proper size it is important. There are another services that you can use in order to provide a scalable unit in more in the compute perspective is, for example, a scale sets. A scale set is a set of VMs that are grouped together into a single group, and they can escalate the amount of VMs that are available to consume requests at any time. So based on the request that comes through the system, you can have 1 VM, 2 VM, 3 VMs, 20 VMs that will vary according to the requirements of your system as well. But this is another example of a scale of unit. You are going to increase your compute based on the demands. Pretty similar happens with the Azure functions, but in this case, we are talking about a serverless service in this case that is going to escalate according to the demands that the user puts to the system. But at the same time, it is important to note that the Azure function based on the planning and the consumption plan that you choose is going to have also limitations. So you go into a consumption plan in a standard plan is going to have a constraint as well. So if you have a high demanding system, you are maybe well served using the consumption with the premium plan. So it is important to know how to scale those units. As another example, we have also the container apps. This is another pretty good example that works pretty similar to Kubernetes, but in this case, it removes all the infrastructure management that you need to do when you are working with Kubernetes technologies. So like we spoke previously, choose event-driven architecture that allow you to scale your applications properly. So as you can see on the screen, this is a pretty good example of a simple application, but it's going to allow you to build event-driven systems that are going to allow your application to survive any outage. So let's suppose a user just sends a request to an API, and this API is going to be hosted into the Azure Container Apps service, and this one has a connection to an orders database. The orders API can actually send a message to a service bus in this case. This is one of the other Azure services that is available for queuing system. You send messages and another consumer can take those messages and process those messages. And you could have another service in the middle that is going to be consuming these messages. In this example, we set up a cost service that is going to be consuming those messages, and it is going to be right into the same database in this case. So we have similar to the AppBox pattern in this case for the development perspective. And when the process actually finish it up, you can use sign alert to notify the user that the process has been completed successfully. So most of this flow can happen async, and if in particular moment let's say the cost service is down, maybe it's under maintenance, maybe there is a not so well planned deployment happening in the process, the service queue is going to hold those messages for you. And when the cost service goes back online, he can start processing those messages again and get up to speed with the changes. So in order to also to build event-driven application, you have to start thinking about services that are going to give you like a flavor of global distribution in your applications. So we have a list of services in here on my screen that actually are going to provide solutions for you. And these services have one particular thing, and they are globally available since the moment that you create them. We have Azure Front Door, we have Traffic Manager, we have Cosmos DB, Storage Account, and Container Registry. These three services have the capability to be fully available throughout the globe. So that means they are available in any region that that you are on. And if there is a failure in the main region that you choose, the service is going to automatically fail over and also support you to fail over into one different region. So Azure Front Door is actually a great service because it combines a load balancing strategy. In this case, is combined with a CDN layer, which actually also increase the amount of availability the service can have. And today, the Azure Front Doors actually leverage over 118 edge zones in order to store the cache into different places, which actually reduce the amount of latency that the user has to traverse in order to get the information. So as you can see, even when this is a global service that could be deployed in terms of the Azure side into one particular region, since you are using Azure Front Door, you connect through from a different regional service, regional location, you will be able to cache your information automatically using the front door service and access that information pretty quickly, even if you are located maybe in Europe, maybe in Africa, maybe in Asia. Front door is going to provide these kind of things. One front door is actually pretty useful when you are writing applications that have ingress into the traffic. That means a web application, web APIs that you would like to expose to the internet, web services, mobile applications that also require protocols connectivity via HTTP, HTTPS protocols. And one of the most important things that the front door has is the Azure firewall. Front door is going to provide out of the box a high security implementation on the middle using the Azure firewall, or also as well known as the WAF service. WAF service is going to provide security to your application to avoid incoming attacks, penetration testing from penetration failures from another kind of thing, and it's going to protect your application in the case of undesirable attacks. But as you can see, between all of those things, when we make a request to the Azure front door, based on the location that you are, you could have, for example, two container apps deployed in different regions. Let's suppose region number 1, it is located in Mexico. And region number 2, it is deployed in the Australia region. Front door has the capability to use a traffic redirect based on the region that you are and the latency that you are experiencing, and is going to send the request to the closest region to you without any other intervention from any human. So if you're closer to Australia, you are going to go to region number 2. And if you are located into in a place that is close to the region number 1, which we mentioned is Mexico, is going to send you request to Mexico. But one of the most important things is that let's suppose that region number 1 goes down or we lose connectivity with it. That doesn't mean your user are going to stop experiencing your product. Front door is going to roll back and send all the information to the region number 2 that is fully available in this case. And when the region 1 goes back online, it is going to start sending traffic once more into this region. Traffic Manager serves a very similar purpose, but in this case, it works throughout the TCP protocol in this case, instead of leveraging the HTTP protocol. And you can send the traffic based on priority, weighted performance, and graphic location as well. So the Traffic Manager is pretty helpful when you want to deviate your users to one particular place based on priority, for example. So you can have priority into one particular region so that region can take more of the load, and only when it goes down or maybe there is a high activity in region number 1, you can deviate the request to region number 2. You could have weighted, like for example, you can say I want a region to take 80% of my traffic and another one 20% of the traffic. Maybe you want to keep a region with a high compute configuration and the second region with a less expensive compute. So you can do this kind of thing. So the secondary region takes actually a lower load. Traffic Manager also provides a performance-based traffic. So that means closer that you are to the application is going to relay the traffic based on the latency that you are available. Also, we can deviate traffic using geographic configuration. So based on the location that you are, you can deviate the traffic from one region into the proximity that the user is. So this provides this kind of configuration pretty easily. Well, now if we speak about Azure Cosmos DB, we have a huge advantage that we are going to have capabilities to work Cosmos DB. just as a NoSQL database. It means a out-of-the-box configuration that I should provide. But in case that you are maybe trying to opt for maybe for a existing flavor that your developers already know, or maybe we want to tackle your approach in a more standard way, let's call it that way. You can use any of the technologies that you see on the slide. You can go with Postgres, Mongo, Cassandra, Table, and Gremlin in order to interact with the Cosmos DB. So you can choose any of those flavors when you are creating your Cosmos application. One of the greatest things about Cosmos DB is that a Cosmos DB automatically by itself is going to keep a replica of the data in several locations for you, protecting your data. Just there is a couple of things that you need to keep in mind based on the demands that you need to have. So as you can see, we have the several level of consistencies that a Cosmos DB could have. It could be a strong, bounded, stateless, session, consistent prefix, and eventual. So what does mean? So based on the consistency strategy, you are going to be making a trade-off between the throughput your system can support and the availability that the data is going to have. So if you choose a strong consistency level, you are going to sacrifice the throughput, but you are going to make sure that all the users that are connected into your Cosmos database are going to have the data mostly replicated automatically. So that means if a user that is located in Europe right into the database, another user that is located in South America is going to be almost in real time being able to see the same data in a different region. The more you go down, the more throughput you can achieve, but less consistency you are going to have within the user. So as an example, when you try to use the boundless statement, you are going to have an increased throughput, but the data is not going to arrive in real time to the end user. So this take into consideration. The more you go down, the less consistency you are going to have between regions. And this also translates into a service level agreement and the recovery objective that you want to have. Because if you have a right into a single or multiple region, let's say using the strongest strategy, that means the recovery point objective is going to, let's start, goes down. So when you choose any consistency level, but you don't want to keep a replication into another region, the recovery point objective is going to be less than 240 minutes. But if you choose to have a single region in this case, and you choose to have session, consistent prefix, and eventual, the recovery point objective is going to be less than 15 minutes. So as you can see, like I spoke in previously, everything is about trade-offs. So you might have a high consistency of your data, but in some cases, when you are trying to recover from an accident, it's going to be translated into more time in order to recover. So if you choose, for example, a single write region, a bounded statement, you are going to be tied to the K and T, where K is the number of versions that is going to be updated in a particular item when you write into the database, and T is going to be the interval that happens between the write and the next update the object is going to have. So you're going to have cases where the information is stored in a single region, but maybe didn't reach out the other region before there was an outage. So everything is about trade-offs in this design, and Cosmos offers a high availability system, and you need to know how to trade off these things: the highly consistency of your data, or maybe the high efficiency of your system. Azure Storage Account provide another high level of resiliency, and this one is going to vary according to the configuration that you opt to have in your application. So if you use the storage account, you can have replicas in a single place. You could have replicas in multiple regions, like I spoke previously. So for example, if you offer a locally redundant replica, it means that your data is going to be replicated in the same data center. So if the hard drive that holds your blobs or your files fail, there is another hard drive trying to keep the information safe for you. That's okay. But if the whole rack where your information is actually being stored fails, your information is going to be lost because all the information is going to be compromised in this case. So maybe you want to move more into the right and you want to keep replicas into a zone where your data it is going to be copied to different availability regions. Or even more, you can go more to the right and try to keep replicas in different regions, and even make sure that the regions serve your clients. So you can provide real access to those regions. So Your data is going to be copied, always targeting one particular region, but the data is going to be replicated into another region. But when you make a read operation, you can use those extra regions to reduce the latency. Then again, based on the strategy that you choose for your data replication, is going to compromise the durability of your data. So the lower that you go, the more probability to lose data you are going to have. But even if you see in the screenshotting here, even when you choose the LRS with the service that Microsoft offers today, he is offering a 99.99 with 11 nines of durability in your system. But the more you go down into the right, you are going to have a more certainty that your data is going to be available, and you are going to be less prone to lose data in your application. So when you want to protect your application in a case of failure, all the services that we spoke of previously are going to offer to you different ways of how you approach your solution. So when you're planning to the disaster recovery, and especially for the high availability design, you can have different designs. One of them is the active design. And in this case, we start integrating part of the services that we spoke of. So for example, you can have front door serving your clients. It means any request that goes to your system is going through front door. We already know front door is a global service that offers a very, very high availability in the Azure side. And you can have your application taking requests to 3 different regions. And you can see we have exactly the same infrastructure created in the East US, in Australia, and in Mexico in this example. And since this is an active design, it means that front door is going to be sending requests to all the regions all the time. So that means all the 3 regions that we have available are serving the user and taking traffic. So this is pretty good because if one of the regions goes down, you have the capability to dial back your users into another region without them even noticing that anything happened wrong into your system. And when the region goes back online, you can then again start sending traffic to your application. So sorry. So if the East US region goes down, the other 2 regions can start taking traffic for you without any problem. And when the region goes back online, you will be able to take traffic once more. Of course, there is a trade-off or something to keep into account into the active design. This is going to be very expensive. So if your company can have the luxury of having the same infrastructure deploy individually in multiple regions and keep it online to attend your client, that's pretty good. But keep in mind, this is the more expensive solution that you can opt up when you are trying to build a highly available system. But at the same time, paying that trade-off is going to give you one of the most highly available systems that we could have in the market with a proper design. Now we could have the active passive design. And in this case, this is when we choose to send the traffic into one particular set of regions and have like another region just as a backup. So for example, in this case, we could have the front door sending requests to the Australia and Mexico regions at the same time, just to keep it open. But we will have another East US region in this case that is going to be ready to take traffic in case something goes down into the other region. Here it comes into place a very special configuration to services like front door, because you will be able to switch traffic based on the weights that the region has. So switching traffic based on traffic per region is going to be pretty helpful in here, because as you can see, as in an example, you can send requests between one application and into the other one and choose a weight and a priority to send the request. So of course that passive region is going to be the one that is going to take in less requests. It is going to be active, can take requests, but it's not going to be the one taking a request as a priority. It's going to be less weighted, and it is not only going to increase the priority and the weight when one of the other region is not fully available. Then again, if we speak about the active passive, there is going to be let's say a hold or a relationship with cost, because we have to maintain multiple services at the same time. And even with the passive region taking less traffic, it's going to incur into charges. But then again, it's going to provide a good availability plan in case of a regional disaster. Now we have the passive call availability design. And this is change things a little bit in here because the things are going to be in a passive state because one of the regions is going to be, let's say, taking a request. Usually only keep one region or one configuration taking the amount of request. And the other one is going to be called because it's not going to be available. So either you have to opt for two things. You only will be sending traffic to the cold passive instance in this case if you want to really to serve traffic that will require manual instruction for a human in this case. Or if you don't even want to have like that infrastructure recreated and only manually configured, you can opt to have a CI/CD processing in order to deploy your application when the demands require. So as you can see, this is going to be the cheapest one, but when the times come, it's going to require manual intervention or sometimes manual deployments or redeployments of infrastructure in another region. So that is going to increase the amount of time that your system takes to recover, but it's going to be the cheapest option that we could opt up. Well, we just mentioned CI/CD, but hold on, before going into how to manage deployments to build successful high availability application, let's talk about a little bit of some of the technologies that are going to make things easier for you. So we have technologies that are treated today as infrastructure as code, when instead of building your infrastructure or treating your infrastructure as a manual process from some of the DevOps team or your platform infrastructure team, if your company has one, you leverage the developers to write the infrastructure. This is actually pretty helpful because all the infrastructure is going to be provided in code instead of manual processors or even with human interaction, and everything is going to be detailed in code. In this case, we have technologies like Terraform. We also have the Azure ARM templates, which is one of the services that Azure has by default. And also Pulumi is actually pretty popular today, and it's going to give you options like this. So instead of trying to create everything manually, you can take advantages of examples like in the left, which is using at the moment Terraform, or example in the right, which actually is using Pulumi. If you take this as an example, this actually is doing exactly the same thing. It is providing a AKS cluster and is providing a very basic configuration in a region. Both are doing exactly the same thing. And one of the greatest things of this kind of configuration is that you can easily try to parameterize everything. This is an example of a ARM template from the Azure side. And you can create custom parameters very easily, like which region you would like to deploy, which compute option you would like to choose. And if you are deploying, let's say, that event hub, how many throughput units you would like to have, stuff like that. And using this code and the automation tools, you will be able to deploy infrastructure pretty easily. Okay, now we can go back in here and talk a little bit about zero downtime deployments and start talking in a few about a more CI/CD approach. So when you are working in a high available system, there is another particular very important piece for the CI/CD integration is that you have to make sure that your application is zero downtime in terms of deployments. So here it comes into play something that is pretty important, and sometimes we let's say skip it. We have to be very rigorous about the pre-release testing. So we have to have proper environment set up where we need to do the testing of our system. The more automation we have, the better. The more our QAs are capable to write automation tests instead of doing a manual testing and making and giving a proper coverage to the test cases, or more stable our system is going to be. Also, we have to make sure that deployments are transparent. That means that if at any moment I would like to deploy a new version to the production environment or maybe to the production environment, we have to make sure that deployments are transparent to the application. So what does this mean? That means when you try to deploy an application, your system should not go offline, sorry, and you should always keep serving your clients. While the application try to make updates, the application should stay online. So the application doesn't know there is a deployment in transit, and even less your end user is going to know there is a deployment in process. So in this case, we can give a good example. We have the blue-green deployment strategy, where you usually have a blue application. You have a blue deployment, and the blue deployment is it is the part of the application that today is serving your end user. So as you can see, we have our blue deployment, which is serving today our client, and we have a set of deployment into the Australia side and also in the Mexico region. When we are making deployment, we can opt for a green deployment. As you can see on the right, we created already a new instance into the Australia center and the Mexico side. Then again, if you are observing enough, we have the traffic manager into the middle. One of the things that traffic manager is going to give us a huge flexibility is actually to create weighted deployments, like I mentioned before, and also is going to provide a very easy out of the box blue-green deployment strategy, because that way you will be able to serve your clients with the existing application and also with the new one at the same time. While this happens, you can make slowly progressions into your application. You can keep the blue deployment and the green deployment and start checking things. So you can see if maybe the green deployment is actually working properly. Maybe there are not complaints from your client. And the more time you spend with the blue-green application, you can start moving into the right. So eventually, your green deployment, when everything is fully stable and you know everything is healthy enough, you are going to have more deployments into the green strategy than into the blue one. So this is a slow pass between the environments until eventually you have your whole new green deployment replace your whole application, and this green is going to turn down into your new blue one. And when you make a new deployment into the future, this new blue one is going to be transitioned into a new green one, and so on. So as you can see, taking advantage of a proper deployment strategy and using services like Front Door, you can make sure that application is fully available even when making successful deployments of your application. Well, in order to achieve that, of course, you will need to have a set of pipelines properly set up. So let's take a quick look into this example. This is an example from the Microsoft suggestion or documentation on how to build a successful pipelines. And you can see we have something pretty important in here. We are not only deploying the application in the release unit, and you can see in box number 3 on the first row, but also on the second box on the same row, we are also deploying the infrastructure. That means we are creating the Kubernetes cluster, we are creating the Azure Kubernetes, we are creating the Event Hub, and whatever infrastructure resource that we need to provide on the platform side. Then when we have the proper infrastructure setup, we can start deploying the code that interacts with a new infrastructure that has been created, and we can progress to deploy the application to the different infrastructure that we created, deploy into Kubernetes, deploy into web app services, deploy the Azure function, and then deploy the workload when you start deploying your application into those resources. Then again, super important, we have a part on the pipeline that is actually the one that is going to give us the test application code, and this is going to be fully automated. Then again, this is important to have a fully automated test in this case. If anything fails in one of these steps, having proper pipeline setups is going to allow you to easily roll back to the previous version without affecting your end user or causing a minimum side effect into the user. So as you can see, once our process has been completed and we give, let's say, a proper setup, we can start redirecting the traffic. Take a look into the last row number 3 into the diagram, into the second column. Eventually, we relay the traffic to the 50-50. So that means 50% of the green is taking the request, and the other 50 is being taken by the blue deployment. Then we can leverage the traffic 100% when we know the application is fully operational. We then again make a test that our application is healthy, just to make sure. Defensive in a proper system, a hybrid system is one of the keys. And once we have everything ready and we are ready to go, we can destroy the old infrastructure and stay with the new one. This is a great example of a blue-green deployment in this case. When we talk about application environments, of course, we are going to have the dev and test and the production environment. And even if you think about it, this is maybe one of the worst practices that you can follow up if you are actually building a successful application. The first thing is that you should not have centralized environments that like they try to live forever with the same resources because that causes issues at the end. So this is the usual strategy that we have. Green, we have a dev test a production environment. And this usually makes things very complicated because the dev environment start being shared between a lot of developers, between a lot of teams. If you have a big company working with several teams, and this contaminates the dev environment and start causing cross issues between different teams and even between the test environment that also causes issues because of the multiplayer deployment. Then again, production is going to suffer the same thing because you are going to be sticking with the same infrastructure, and that is not going to be always super healthy to follow up. So then again, here it comes into place and a strategy to have pipelines in order to deploy things. So when a team want to validate something and do a proper testing, they should have different life cycles in this case. So yeah, we should keep multiple dev environments that allow individual teams to test features individually without making a compromise of the different infrastructure. Same applies for the QA and staging. Just need to make sure to have multiple environments based on the features that you are going to be deploying, just to make sure that you have different environments that allow the quality assurance to test those components individually without making sacrifices or having everything mixed all together. When you want to build some of the high ability systems, or also known as business continuity and disaster recovery strategies, you can leverage into another services that I invite you to take a look, like Chaos Studio. This is essential and very fundamental for proper testing. Azure Landing Zone. This is actually a great tool or design in the Azure side to structure your company and your resources group and how you split your application properly. These pools, this is actually pretty important tool because it's going to allow you to maintain and keep replicas of your disk that you manage manually and protect those. Service health, like I mentioned, just to make sure that your services are healthy and good enough. Azure Site Recovery could be pretty helpful, especially when you are trying to keep, let's say, an active or an active passive solution between the Azure side and on-premises services. Front door can allow you to build these kind of things. And Azure Site Recovery, it is going to allow you to recover your infrastructure, let's say in a case of on-premise failures, into the Azure side very quickly and vice versa. Azure Backup, as the name says, it allows you to keep backup of important information, databases, hard drives, and stuff like that you can restore at any time in the Azure side. Restore Point Collections is actually a very new brand service that Azure has, and it's going to allow you to build collection or restore points of different services and different backup strategies and restore all those together at the same time. And also adding to addition recovery service vaults that actually work pretty well with Site Recovery and Azure Backup in order to protect your data, keep replicas of your data, and allow you to recover in the case of an accident. Okay, all these services allow you to build successful application, and I shared you some of the most basic strategies that you could follow up in order to build successful applications. So I would like to know if there are any questions to answer.
Guys, you can leave your questions in the Q&A side, or maybe if you'd like to ask Santiago directly, you can raise your hand and I can give you the option to talk in case there's anything you'd like to discuss. All right, Santiago, I think everyone is reacting pretty nicely. I don't know if you've seen, but there's no questions. There's just like applause and all of that. So I congratulate you for a very nice talk. And thank you everyone as well for joining us. And remember that you can stay in touch with us in social media, LinkedIn, all of that. And stay tuned for future talks that will contribute to your knowledge, such as this one. And thank you all. Thank you again, Santiago, for all the knowledge that you share with us. And everyone have a great rest of your day.
Thank you, everyone. Have a good one.